This is problem number 10 from section 3.7. And this problem says find the lines that are tangent and normal to the curve at the given point. They give us an equation y equals 6 sine of pi x plus y. Notice that we have y on each side. So we're going to have to find the derivative of this using implicit differentiation. And we want to find the derivative because they're asking us to find the lines that are tangent and normal, so that means we need to find the slope. Once we know that slope's the tangent slope. And then we know the normal slope is going to be perpendicular to that tangent slope. So let's go ahead and just start taking the derivative from left to right using the implicit differentiation. Derivative of y is just 1 dy over dx equals, let's do the derivative of the outside. So we need to bring our trig functions out. So this is going to be chain rule. Remember, we have a function inside of a function. So we're going to do the derivative of cosine, or derivative of sine, I should say, is cosine. So this is 6 cosine pi x plus y. But because I'm using the chain rule, I need to multiply by the derivative of the inside. Well, what's the derivative of pi x? Well, that's just going to be pi plus derivative of y will be dy over dx. Now, I should have probably written 1 dy over dx. That's what this is, but it ends up being dy over dx anyways. So let's go ahead and now distribute and then get dy over dx on the same side over here so that we can factor it out. So this is dy over dx equals, when we distribute the 6 cosine, we end up with 6 pi cosine pi x plus y plus 6 cosine of pi x plus y dy over dx. We're going to subtract this to the other side, so we're going to subtract negative 6 cosine pi x plus y dy over dx to this side. And we end up with dy over dx minus 6 cosine pi x plus y dy over dx equals 6 pi cosine of pi x plus y. Let's factor dy over dx out, so we end up with dy over dx. We have 1, because that's what's left when you factor out dy over dx, minus 6 cosine pi x plus y equals 6 pi cosine pi x plus y. We're going to divide this over to this side, so we end up with dy over dx equals, when we divide this, or I should say divide this to this side, this is now in the denominator, so we have 6 pi cosine pi x plus y all over 1 minus 6 cosine pi x plus y. So this is the derivative of our original equation. This will give us the slope. So we want to say slope at 1 comma 0. So what's the slope at 1 comma 0? Well, we're going to just go ahead and use this equation. So dy over dx equals, let's plug in 1 and 0 into this equation. So we have 6 pi cosine, we'll have pi times 1 plus 0 all over, on the bottom we'll have 1 minus 6 cosine of pi times 1 plus 0. So when we evaluate that, we end up with, well, this will just be 6 pi cosine of pi over 1 minus 6, this will be cosine pi. Well, we know cosine of pi is equal to -1. So we're going to say that this is -1 and this is -1, so we have -6 pi on top over, and this will be -1 here, so it's 1 plus 6. So we end up with -6 pi over 7 for the slope. So this is the tangent slope. And the normal slope is the perpendicular of that. And the perpendicular of this -6 pi over 7, well, we just flip it and then we're doing the negative reciprocal. So we're going to get rid of the negative and then flip it, and that'll be 7 over 6 pi. So let's go ahead and say that we're finding the tangent line at the point 1, 0 and the normal line at the 1.10. So we can say that y equals mx plus b. Let's plug in 0 for y, 1 for x, and then the slope at the same time. So 0 equals -6 pi over 7 times 1 plus b. We multiply and then add that over, that'll just be 6 pi over 7 equals b. So now we can say that b is 6 pi over 7, so our tangent line is y equals -6 pi over 7 x plus 6 pi over 7. This is the tangent line. The normal line then is going to be, again, 0 equals 7 over 6 pi times 1 plus b. We multiply this and subtract it over, we get -7 over 6 pi is what b is. So we can say that y equals 7 over 6 pi. This would be x minus 7 over 6 pi. So this is the normal